Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Senpai. Welcome back, everyone. Today we're jumping into an 11th grade topic, finding complex roots. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions what we see today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Senpai and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist, in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have 2 parts, so leave a like, smash subscribe, and let's get started. At this point in time, you should be very familiar with how to find your roots of an equation. So let's say we had an equation like this. X squared minus 1 equals 0. If I was to ask you, find the roots of this equation, this should be a no-brainer. This is a rather simple one. In fact, you can even tell me how many roots we're expecting simply by looking at the highest power of this equation, which would be a 2. This is a quadratic, which means that we're expecting 2 roots here. And we know that those 2 roots are going to be x equals plus and minus 1. This is something that we've had a lot of practice with. However, let's say we had, instead of x squared minus 1, we had x squared plus 1. If I was to ask you to find the roots of this equation, in the past, you may have been a little stumped, because what is a root? Well, a root is just going to be where your equation equals 0, right? What are you plugging into your x to make your equation equal to 0? And if you were to plug in anything into this x, it's not going to equal 0 because everything is positive. So you may have even said there were no roots here because you can't get this equal to 0 in the past. However, that's only going to be true if you're focusing on the real numbers. Now we know about imaginary numbers and complex numbers, so I think we now have what we need to tackle this type of question. So let's solve for the roots of this equation. We know that we can simply move things around. X squared equals a negative 1. And if we take the square root of both sides, we know that we'll have x equals plus or minus, don't forget your plus or minus, square root of negative 1. And because of what we know about imaginary numbers, we know that the square root of negative 1 is just going to be I. So x is going to equal plus or minus I. So just like we expected, we did have 2 roots. However, they were not real roots. These are imaginary roots. We have I and we have negative I. And this is okay. We don't need to have real roots. The main thing about your root is that when you plug it in, it makes this whole equation equal to 0. So let's check our work and make sure that this does indeed force this equation to be 0. If we were to plug in an I into our x squared plus 1, we would get what? I squared is going to be I squared plus 1. And what is I squared? Well, I squared is going to be negative 1 plus 1. And does negative 1 plus 1 equal 0? Yes. So we know that that one pans out. How about our negative I? If we plug in a negative I here, well, negative I times a negative I is going to make that negative go away, and we're going to be left with, once again, an I squared plus 1. And we just did this. I squared is going to be a negative 1 plus 1 equals 0. Once again, we have verified that both I and negative I, when you plug it into this equation, it forces it to be 0. Thus, these are going to be your roots, imaginary roots, of your equation here. So just to reiterate, it doesn't matter if you're real or imaginary, as long as when you plug it into your equation, it forces it to 0. Those are going to be your roots. So now that we talked about finding our imaginary roots, let's move on to our example for today. So for our example for today, we have 4x squared minus 3x plus 2 equals 0. And we want to find the roots of this. Now, spoiler alert, it's not going to be real. But once again, it doesn't matter if it's real or not. We want to just find our roots. And we have a lot of tools to help us do that. So today we're going to use our quadratic formula to help us with this, because this is a quadratic equation. And remember, your quadratic formula is minus b plus or minus the square root of b squared minus 4 AC all over 2A. So we're going to simply take this and plug it into our quadratic formula and see what we get. So our negative b is going to be a positive 3 now. We got a positive 3 plus or minus. We have negative 3 squared, so that's going to give us a 9, minus 4 times a, which is 4, times c, which is 2, all over 2 times a, well, 2 times a, which is 4. So we can simplify this a little bit. 3 plus or minus the square root. We have 9 minus 4 times 4 is 16, times 2, 32, all over 2 times 4, 8. And we can further simplify this to 3 plus or minus the square root of what's 9 minus 32? A negative 23 all over 8. Now in the past, you may have stopped here because you have a negative under the square root. Couldn't do that. But we can actually do that now. So I'm going to just rewrite this a little bit tighter. Negative 23 over 8. Just to give us a little room. We know now that we can break this up into negative 1 times the square root of 23 here, right? Just break up our square roots in this fashion, which means that we can simplify this to 3 plus or minus I, right? The square root of negative 1 is going to be I, times our square root of 23 all over 8. Now technically you can stop here, but let's say we want to go a little bit further just to make sure our answer looks like complex numbers. So here we have our answer. The first thing I want to do to make it look like a complex number is let's rearrange this I, right? So instead of having I up front, we're going to write this as 3 plus or minus the square root of 23 I all over 8. Now the next thing I want to do is let's break this apart because your complex number has a real component and it has an imaginary component. This is all one big thing together. So we want to break this apart. And we can do that by doing 3 over 8 plus or minus the square root of 23 I over 8. Now we're almost there. You know that you can rewrite this. Instead of having your I up top, we can rewrite this as 3 over 8 plus or minus the square root of 23 over 8 I. And this would be the final answer in complex number form. You have two roots. You have your plus and your minus. If you were to write all of this out, it would be 3 over 8 minus I. So you would have 3 over 8 plus the square root of 23 all over 8 times I. And you have 3 over 8 minus the square root of 23 over 8 times I. Now that we know about our imaginary numbers and our complex numbers, solving this for our roots is not going to be any problem. So I hope you were able to follow along with today's video, and I hope you understand now how you can find your complex roots. However, if you have any questions about what you saw today or even on homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. But that's all the time I have for today. I really hope this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney. Here's your playlist, and this has been another session of Tutor Me Sempai.